This tiny device is the MPU 6050, which is gyroscope and accelerometer sensor. Some of you may already know what this is. If you don't, I'll give you a rough explanation. Accelerometer measure linear acceleration in three directions x, y, z, indicating changes in speed. Gyroscope measure angular velocity capturing rotational motion around a specific axis. Both sensors are crucial in motion sensing technology. It's widely used in phones, drones, gimbals, etc. If we connect this sensor to a microcontroller like an Arduino Nano, make the connections, and upload this simple code, you can see some data on the serial monitor. As I tilt or move the sensor, the readings also change. Now here we have an ultrasonic sensor. This is the most commonly used sensor in Arduino projects. Ultrasonic sensors use sound wave beyond human hearing to measure distance or detect objects. They emit ultrasonic pulses and measure the time taken for the echoes to return by calculating the distance based on the speed of sound. Let's make a simple project using an ultrasonic sensor and an Arduino board. It's a straightforward project that will measure the distance. Now we have to upload these codes. If we run the serial monitor, you can see it's working. As I move my hand closer or further from the sensor, it measures the distance. Pretty interesting, right? Here we have both of these sensors along with the display and Arduino Nano. If we combine all of these, we can make something like this. It looks complicated, but let me explain. I plan to make a tool like a digital spirit level or bubble level. It will also measure the distance. Let's see if we succeed or not. So we begin working on the codes. By the way, this is my brother. He's the one who works on the code and brings my project to life. So these are the codes that we came up with. Let's just upload them. Now it's time to power this thing up and see if it's actually work. As you can see, it's working. However, I'm not sure if it's accurate or not. This tiny button right here is for changing the modes to distance and horizontal spirit level. Anyway, we can't use this project like this. We have to make some kind of structure to make it more convenient. That can be achieved by a custom PCB board. So I start designing the schematics and PCB board. After completing the design, I created the Gerber file and ordered the PCB from JLC PCB. JLC PCB is a highly trusted and popular PCB manufacturer. They provide PCB prototyping services at very low cost. Besides PCBs, they also offer PCB assembly, SMT stencils, 3D printing and CNC machining. Just upload your Gerber file and order your PCB of any color mask for just $2. My package arrived within 7 days and I used the white color mask. I think it looks much better than green or any other color. It's just my opinion or choice. The quality of PCB is top notch as always. Now let's gather all the parts and assemble the PCB board. A big shout out to DF Robot for providing me all the necessary components for this project. You can find all the links in the description, so be sure to check them out. Now let's get started. Alright, so the project is nearly complete and it's looking quite impressive. Now let's power it up and check its functionality. Finger crossed, and there we go, it's up and running. The vertical level mode is working perfectly. I don't know it's accurate or not. Let's switch to horizontal mode. It's also functioning well, and so is the horizontal mode. However, we still can't use it this way. We need a housing to install everything securely. So I began designing the housing using Fusion 360. So here's my design, not too shabby. Anyway, let's 3D print the design using my 3D printer. Okay, so the housing turned out quite nice. Now let's install all the electronics into it. Finally guys, the project is complete and I'm quite pleased with how it turned out. It looks pretty interesting, feels like nothing spirit level. Anyway, let's power it on and see if it's actually useful or not. Firstly, we need to calibrate the device. So place it on a flat surface such as this table. However, before proceeding, let's ensure that this table itself is perfectly level using a traditional bubble level. As you can see, it's not, so I have found another table that is at ideal level. We'll calibrate our device on this table. The calibrating process is straightforward. Just press and hold the button for 2 seconds and then release it. This will initiate the calibrating process. Okay, so it's done. Now let's determine the table we previously checked. And we can see it's flashing between 0 and 1, whereas it should display a constant 0. If I lift the left side slightly, it stops fluctuating, indicating the perfect level. Confirming with a traditional bubble level gives the same results. Impressive. Now let's try out the distance mode. I'm using measuring tape to verify the readings for accuracy. I would say it's doing the job, but it's not that accurate. Although it gives a rough idea of how far the object is. It seems it has an error of approximately ± 1 centimeter. Overall, the device isn't highly accurate, especially when used vertically as demonstrated. However, we'll address these issues by changing the codes and attempt to enhance its functionality, including finding different angles. You can also contribute to making this project more accurate. All files are available on the github.com. So that's it for this video. It was a really fun experiment. I hope you enjoyed the project. Make sure to subscribe my channel for more upcoming videos. Thanks for watching and I will see you in the next video. Until then, bye bye.